Hello, discrete math fans. Let's talk about the inclusion-exclusion rule. Now, we talked about the addition rule, which tells us how many elements are in the union of sets, but they have to be disjoint sets. What do we do if the sets overlap? All right, well, let's look at a Venn diagram. Here we have the sets A, B, and then their intersection is shown in the middle. It's not all that hard to see that if you want the number of elements in the union, you can count whatever's in A, count whatever's in B, but then you have to subtract off the overlapping, because by counting A and B, you will have double counted the things that are in the overlap. This is the idea behind inclusion-exclusion. You include the things that are in A and B, and then you exclude the overlap because of the double counting. So counting the elements in A and counting the elements in B end up counting the overlap section twice. Now it's a little harder to see how to do this with three sets. The book goes through an explanation of how you can do this. I think we're just going to state the formula when there are three sets. So the theorem is the inclusion-exclusion rule for two or three sets. Now there's a more general version of the inclusion-exclusion rule, which is a little more complicated. Maybe I should say it's a lot more complicated, but the idea remains the same. So inclusion-exclusion says that the number of elements in A union B is the number of elements in A plus the number of elements in B minus the number of elements in the intersection because of overcounting. And if you want to count the number of elements in A union B union C, well, then you can count whatever in A, whatever's in B, and whatever's in C, and subtract off the overlapping parts, which is the number of elements in A intersect B minus the elements in A intersect C minus the elements in B intersect C. But then, interestingly enough, you actually have to add back in the number of elements in A intersect B intersect C, because by subtracting in the second stage, you've actually subtracted off too much. And again, this is pretty difficult to see with a Venn diagram. You can, with a little bit of work, see what's going on, but it takes some time. So we won't do very much more with the proof. You can read through it yourself if you're interested. Okay, that's all for now.